Here we go. Okay, so today, welcome. Thank you for watching. Today we're going to be going over environments that are used for data collection and running our agents for reinforcement learning. I'm going to go over a couple quick things about the environments themselves, what the common loop is, and a generic environment that you can get from Tensorflow, and I'm going to show you how I build my own environments. And there's going to be there's going to be several agents, and a lot of the agents are similar. It's just I implement it as continuous or discrete, or I have a network, be a convolutional network or an RNN or an MLP. Same thing with the environments. They might be set up different depending on the task and my preference. Because you're building your own code. You can adapt things how you like, which is why I'm going to show you this instead of just walking you through the TensorFlow version. But yeah, for the environments, we're gonna have different videos on how to integrate. Well, first we're gonna have a normal PyBullet tutorial, and then after that, I'm also gonna show you how to incorporate PyBullet into the environment. But we're just gonna have a simple grid world environment for today. And even to call it a grid world is a bit of a stretch. We just have it. I guess you could just call it a pathfinding, without boundaries. So it's not really a grid world. But let's just talk very quickly about the common workflow. So here's openai.gym.com, gym, and whoops, let's go to the home. How do we exit? Oh, here we go. So Gym will provide you with a bunch of easy to use environments right out of the gate. You just have to have Gym installed, and for classic control you don't need anything additional, but for robotics or Majoku or the Atari ones, you're gonna have to have more things installed. But for these examples, we're gonna go over the classic control problems in general. So you just need to make sure you read the documentation, and I think it's pip install Gym or something like that. It's just install Gym, and it will give you these environments that we will be using. But some of the better environments are like that for Majoku or for robotics. But instead of showing you how to use Majoku or the robotics packages from Gym, I'm just going to teach you how to build a normal environment, and then how to load models into PyBullet, and then how to make a PyBullet environment so you can learn on those PyBullet models instead of having to do a whole bunch of installs. Because if I have to do installs or build a new environment, I'd rather build a new environment, because it's you're missing this dependency. It's there. Anyways, sorry, a little bit of a tangent. But yeah, here's the common workflow. You need to make sure you import Gym. You need to import it and define which environment it's gonna be, and you can just access, and you call gym.make, and you just have to know which environment you're loading beforehand, and they have text descriptors. So cartpole v1 is a common one, that's the cartpole v1. So what typically happens is our environment is providing observations. Observations reward whether or not the episode is done, and some more information back to our agent with every step. So we have to make sure to reset our environment in the beginning, and this is just running through, and I'm gonna actually pull this so you can just go ahead and copy this into a text editor or something. I copied it here, and there was a line that said env.render, and since I'm doing it in Colab, you need to have something additional to play it. However, if you were to just copy this to Atom or a text editor, if you have Gym installed, you can do env.render, but since it opens up another window, you can't do that in Colab without getting an error or writing some additional code. This is just gonna sample 1,000 steps from the environment, the cartpole environment. So to get the observation, you have to call environment.reset, and that will give you the first observation. However, you see we just tell our agent, which right here it's just selecting random actions, but in an actual workflow. You're gonna have an actual agent that's learning and selecting the actions for you. I mean, there are some agents like that are like almost entirely random. So I mean, I guess you could work like that and learn from that experience gathered. Anyways, so you take the action that your agent gives you, and you input that into the environment, and you will call something like environment.step on that action. So you're moving one time step forward once you're given that action, and the environment will tell you what the next observation is. So this is like the next state, the reward from the previous state, given that action, whether the episode is now done, and some additional information. And in general, you can go ahead and ignore this info, because what I'm going to be, this is really like extra info in general. I don't like to say that, but that's what it really is. It might be very specific environment things, but for the most part, you can ignore it. And my setup is going to be slightly different. And just letting you know, if the episode is done, reset the environment. That way, like if it's saying it's done, we want the environment to go back to its initial state or whatever the starting state could be, so we can run another or the same agent on our newly initialized environment, so we can gather more experience and train more. So I'm just gonna hit play, and I have it printing out our observation, the reward, the done, and the information. You can see here even there's like no additional information, but this is the observation. This is the reward of 1. This is whether or not it's done, which is false for like most of them. Here's a true, but most of the time the environment's going to be run unless it's the last time step, which is the only time that done should be true. And yeah, so you want to know like what are the potential actions you can take, and what are the potential observations you will see. Like you need to know the shape. So like for the observation, it's obviously like an observation size of like 4, because there's 4 values in the observation space. But as far as actions, you obviously have to do like your own homework and like make sure that you know what types of actions it takes. You can't be giving it up, down, left, right if it only takes up and down or left and right actions, or whatever. Or it takes continuous values and you're giving it discrete. So this is all stuff you have to look at beforehand. So I'm going to go ahead and close Gen, and you can go ahead and actually use an environment from Tensorflow, and I think they're decent. I actually ran several code examples on them. The one thing that I don't like about Tensorflow is I know it's fast if you use like tf.function as a decorator for a lot of your functions, but it just makes things complicated for me for some reason. So I mean, that's why I moved away from it in general. Like I'll use like it as like a setup, but I don't like going 100% in on TensorFlow and everything that they offer. But to learn about the environments, the documentation for the environments, go to tensorflow.org, go to learn TensorFlow, and this is just the way that I navigate the site. And we go to tutorials, go to reinforcement learning, and it's going to take us to TF agents, which can also be accessed through the resources page. And it just gives you the overview of setting up an agent or whatever. But we're going to go to guiding tutorials, and then we go to environments. And obviously you could go ahead and read this on your own, but it tells you pretty much just what I have just told you. And like for example, when you're setting up environments and you want to go all in on TensorFlow, like the agent has to know what the observation spec and what the action spec are, and it includes that in the environment. When if you're working with a couple specific environments that you're like you have a job or a project that you're working on, you're gonna know what the observation space is, so you don't need to have that built in to it. But I would advise people to go through these tutorials, and I think they're pretty good. But you can see it's a little messy, and like you have to be fully involved in it, because some of them are Python environments and some of them are TensorFlow environments. So I mean, there's that. So I'm just going to go ahead and skip this. Just wanted people to know that this is available, and it's a great resource as well. But let's just talk about how I make my environments. So, like, I guess the one difference between my environments and the environments that you'll see in a lot of places is each time you take a step, it'll return the observation for the next state. And that's just something that I don't do. You have to explicitly like call or ask for the observation, like the same way here that you get returned in reset. You'll go ahead and see it in our own code. So I'm just going to go ahead and delete this. And we're not going to run this on anything. We're just going to look at how to build it. And in future tutorials, we'll import this environment and run it on one of the agents that we build, like the simpler agents that we build. So pretty much all we need is basic Python. We need some NumPy, so import NumPy as np. And we need our random module because we're going to be, this is going to be like a random environment instead of just like, the objective is completely static. So what the objective for this is, I called it one target grid world, and you know, in other ones there's going to be multiple targets, and we're going to be using RNNs to solve the problem, because of the issue of, you know, how much information is in the state, and you know if the agent has to remember from experience, or the or you know, part of it, the experience that it's learning is directly from the state itself, like the observation state. And we'll cover that in the RNN tutorial. But anyway, so for this one, it's pretty much just, there's a goal that an agent has to navigate towards, and there's no boundaries, there's no board boundaries. So just think of it as two-dimensional space, and there's 2 points picked in two-dimensional space, and the agent has to navigate to the goal position. Like the agent is 1 point in space, and the goal is another point in space, and it just has to navigate to that other point in space. There's no board boundaries. You know, just imagine an entire 2D plane, and it can go like literally so far, you know, without hitting a board boundary. But obviously, that's not going to give it positive, or you know, or good experience. Anyways, that's what this one target grid world environment is supposed to be doing. Let's talk about how to set it up and how simple it is. There's actually, what is it? It's like just a few functions inside of this environment class. So we're going to define our environment as a class, and you'll see the loop that we would have for a discrete environment like this one that we're going to have set up. So we're just defining a class. Give that class a name. I'm just calling it one target grid world. And then we need our class constructor. We're not inheriting from anything. So we can just go ahead and initialize our class. And we need to define a state, which is going to be for our observation. And we need to know how many steps you know, an episode is, or how many steps we've taken in our environment. So we're going to initialize the step counter to 0. And we need to define a function to actually create our state. So like I told you, the state is just a 2D plane. So we're going to have x values and y values, and these actually only need to be in the range of 2 and 2. Oh, well, it's because I selected high values. I mean, you know, I was trying to do multiple goals, but this could be like 0 and like 1 and 1. And now it's a lot more clean, actually, but it's the same. Oh, can't do that. It has to be 1 and 1. So, you know, what we're doing is we're taking a random sample of values from 0 to 7. So we have 2 random samples for our starting x positions, and 2 random samples for starting y positions. And then we just go ahead and index those and call them like our first piece position and our player position. And we're just indexing our x's and our y values to put them on that 2D plane. So so each of these pieces has 2 values. So the positions for both of our objects, which is our player and our goal state, is what's called 4 values. So this is going to be like a 4-dimensional, well, not 4-dimensional, but it's going to have 4 values for our state space or observation space. And in this environment, our observation space is going to be the entire state space that we can see, because there's the whole thing of an observation could be only part of the state space, or an observation does not capture the entire state. But for this one, it is, because it's an extremely simple problem. Okay, so that's going to be our position. So this is going to essentially be our state, and since we're returning those positions, it gets returned. Self.state calls init state, and our values get returned there. So now we have our state in self.state. And in our update function, since our state is our state and observation are the same thing, we're just going to go ahead and whatever we're going to have like 4 values. Whoops, I have like 4 values here or something, just arbitrary, our x's and our y's or whatever. And we're just going to go ahead and we're going to be modifying these values. Like, oh, we moved up. That means the x for our player, our player goes first, right? That means that the x for our player gets increased. Or we move down, that means our y for our player gets decreased, and etc. Anyways, so now we've defined our state, and our state has been initialized. Once the constructor is called and everything is set. So we also need to have some code for when we reach the termination of an episode. We need to be able to reinitialize our state to its starting state, and our entire environment is has to be reset, because this is now an agent is going to gather new experience, and it has to see it has to go through like the environment again, so you need to reset the environment. So if we're ever done, we're just gonna call environment.reset, and what that's going to do for us is that's going to reset our state for us. We're reinitializing our state, and we're resetting our step counter back to 0. So if we're 150 steps in, hit termination condition or whatever, we're going to reset it to 0, and we're going to go back to a new state. So we're going to get a new starting position for our player and our goal. Okay, so next thing, which is the last thing, is just we need to step our environment. So the environment is gonna take, it has a specific observation. The agent asks the observation, hey, let me see the observation, and it does that by saying, it actually looks inside of the class for us. We're not gonna explicitly like define a function just to return the state. Of course, we're just gonna call once we initialize our class, we're going to call class.state, and we're going to see what the state looks like. So that's our observation. So our agent takes the observation from our environment, and it selects an action, and it's going to return the action to the environment by calling environment.step with the action as an argument. So now that we've been given an action by the agent to our environment, we need to update the environment given that action. So that's what happens inside of our step function. So first thing we do is we increase our number of steps, so we're keeping track of our steps. And typically you will have you could have several losing conditions or different types of winning termination conditions and several different types of losing termination conditions. But for this one, we just have one of each. And then there's the condition where, oh, well, we haven't won, we haven't lost as well. The game just continues. And, so that's typically how the inside of the step function might look like. So I opened mine with a losing termination condition. So we're just saying, hey, if like our agent takes more than 25 steps inside of our environment, we're going to reset our environment, and we're going to return a reward. And we're going to go over rewards later. I just picked this arbitrarily, which is just, this is our losing condition. So it receives a reward of -10. Like that's the losing reward. Like, oh, you did bad, -10. And we now say playing is false because it's no longer playing, because it's now in its termination condition. And we go ahead and we return the reward and whether or not it's playing. And for the other ones, we would like for OpenAI Gym, what it would do is it would return like self.state, and we would take that on the outside as observation, and we'd collect that, but we're going to explicitly ask for it in our own loop. Okay. And there's really not like a huge reason why I did that, just my own personal difficulty when, state next state, when it returns it, when you're asking for it and defining it. So it just made it easier for me, and you can do it however you like. That's just how I did it personally. And then we have a winning termination condition, and this is just to check if our X's and Y's for our goal and for our player are in the same place, which means our goal position and our player are in the same position, so one is on top of the other. So we've now reached our goal. So this is a winning termination condition. So we're going to say reward of 100, and we're going to say playing is still equal to false because we've won, so we're not playing anymore. And we're also still going to reset the environment, and we return our reward of positive 100 and whether or not we're playing, which is false. Okay, so these are our winning and losing termination conditions. And for other environments, you might have like 10 losing conditions and 20 winning conditions, whether you get the goal, or you hit the certain number of points, or you get certain number of checkpoints, or eliminate a certain number of whatever. Anyways, so our agent is going to be selecting discrete actions, so it's given 4 options, and it makes sense why TensorFlow wants to define all these things, but you could just include this like at the top, saying the observation space is for 4 actions, and the action space is also for 4 actions. I mean, for observation is for the 4 positions, x, y, x, y, and the action space is for the 4 different directions you can navigate in a 2-dimensional plane. So we're going to be receiving actions of values 0 through 4, so 0, 1, 2, 3. And we just need to go ahead, and since we receive that as just as 0, 1, 2, or 3, we need to be able to decode that. So we say shift it over in the plane. Like if it's 0, that means up, which just means our state goes down by 1, or and I actually did this like the way that a photo would be, in code. So it's actually flipped about the x-axis. So that's a little bit confusing. What you're saying, oh, y is up. Why are you removing 1? You should be adding 1. But that's the way that I just did it. So this is just some boilerplate right here that you're like, translating the actions into actually shifting over the player position. So that's all this does, which is it's just updating that state. So tell the state, hey, shift over 1 to the left, 1 to the right, 1 up, or 1 down, or whatever it is. And then we're gonna have our state, and we need to know what our reward is. So since this is kind of like this part of our step is saying we haven't won, we haven't lost, just take the action and update the state. So we're actually updating the state right here. But we still need to let it know what the reward is, and if we're continuing to play. And like I said, in the future we'll define how we would define a reward function, and reward functions in general for these simple environments can define it very arbitrarily. But we're just saying, so each step has a cost of -1, so it incentivizes it to take fewer steps, so it can learn, and we just return the reward and whether or not it's playing, and that's our entire environment. That's literally it. It's maybe, I don't know, like 30 lines or something like that. And here's the training loop that I use when I'm using this environment. So we're just defining an episode stepping function, and it takes an environment, which would be one target grid world, and it takes a model, which will be our agent, which we'll look how to build in the next tutorial. And we call environment.reset, and this is on our environment, and our environment should already be instantialized before it gets passed. And we say playing is true, and this is just we say while playing is still equal to true, we take our observation from our environment, so we call environment.state, and we need to add a batch dimension to it because this is going to return our environment.state, but we're going to pass it to a model. And maybe I'm giving you a little too much information right now until you see the model. But we have our environment.state and we need to put it into a batch dimension, and that's going to be our observation. And we add the batch dimension by tf.expand_dims on the 0th dimension. And then we call our model on the batch of observations, which is just a single observation, batch size of 1, and it returns action logits. And we use those logits to create a categorical distribution, which is going to give us back, what is it? Yeah, thought there was a sample method in here. Yeah, maybe I deleted that. And if I'm confused now, you'll see in like the next one that literally the very next video where we're going over the simplest reinforce agent, that there may be a sample method in here and I'm missing it. But this, anyways, it gives us action logits, and from those logits we're going to end up with a 0, 1, 2, or 3, which is the selected index for the actual action that we're going to take, and we're going to end up with an action index. Okay, and then we just call our environment.step on that action index, and we know what our reward is and if we continue to play. And in the next tutorial we'll see what we do with these values, because those are for the agent. And then it just continues into this loop, and we get our new observation instead of getting observation here and then observation equals old new observation equals old observation and like all that stuff. But that's about it. This is like the basics for an environment. Very simple. Make sure you have a constructor where you're able to initialize the state, you're able to reset the state, and you're able to step your environment, and that's as basic as you can get. But yeah, I hope this was somewhat helpful to you if you're watching, and I will see you all for another tutorial for the reinforced discrete agent in a future video. That should be the next video that comes out, and I will be recording that probably tomorrow. I'm trying to do 1 video a day roughly, just going over a lot of old code, and like I said, it's old code, so I read it once, twice, 3 times before going over it for the video, but I don't remember everything exactly every single time, but I'm giving you the gist, and I remember the issues that arise, so I can still help cover those things. Anyways, have a nice one. Take care. Yeah, like, comment, subscribe, share.